It began as little more than a faint flicker, barely noticeable in the endless stream of sky data. A cold speck, moving with impossible speed, far beyond anything that should exist in the outskirts of our solar system. From Hawaii to South Africa, observatories picked it up almost at the same time. Alerts poured in, and soon NASA stepped forward with confirmation. An unlisted, unknown object was racing toward us from interstellar space. At first, astronomers assumed it was just another fragment of cosmic debris, a wandering stone from the void. But the anomalies piled up quickly. Its speed defied natural limits, its course was unnervingly exact, and its surface reflected light in ways no asteroid ever had. When researchers traced its path backward, the truth struck harder. This thing wasn't just passing through. It was heading directly into the center of our solar system. The James Webb Space Telescope turned its mirrors toward it. What it revealed wasn't just unusual, it was something that humanity may not yet be ready for. Because if it wasn't just a visitor, then it might be something watching. Between June 25 and June 29, the Atlas tracking system locked onto it. The object was given the name, 3I Atlas. Unlike the icy comets and rocky bodies catalogued before, this one broke every rule. It raced along at more than 152,000 miles per hour, following no orbit we knew. Its trail pointed not to the Kuiper belt, nor the Oort cloud, but to the emptiness between the stars, suggesting it had been adrift for thousands of years before crossing our path. That timing alone raised alarms. Before 2017, no one had ever seen an interstellar object. In the years since, 3 had passed through, and each was stranger than the last. Oumuamua in 2017, elongated and accelerating in ways physics couldn't fully explain. Borisov in 2019, faster and more unstable. And now, 3I Atlas, brighter, sharper, and far more disturbing. Webb's instruments began peeling away the mystery. The object appeared bright enough to be enormous, yet measurements suggested it was oddly small. Its reflective surface behaved more like polished alloy than stone. Some speculated it might even be hollow. From the start, 3I Atlas looked like a hybrid, carrying the unexplained acceleration of Oumuamua, the comet-like trajectory of Borisov, but fitting neither category. Its spin wasn't chaotic like most space rocks, it rotated in precise rhythm, with one side consistently absorbing heat, almost as if shielded by design. Webb picked up faint but steady thermal signatures, structured rather than random. Then came the most unsettling observation. The object was making controlled course adjustments. No jets of gas. No visible propulsion. Yet its path shifted in deliberate, surgical steps. Spectral scans added another layer. Carbon-based compounds arranged in ways more like engineered material than geology. Electromagnetic flickers hinting at compartments or layered structures inside. This was no mere chunk of rock. It behaved like a machine. And if it was a machine, then someone built it. At that moment, quiet speculation spread through research circles. Not what it was, but who sent it, and why. Then, suddenly, the flow of public information stopped. NASA, ESA, and other agencies that had been sharing updates locked their data behind secure networks. Open databases froze. Observation logs vanished. Independent astronomers reported strange technical blocks. Journalists found only vague, redacted answers. To some, the silence was more telling than the data itself. If 3I Atlas truly was artificial, it would shake more than astronomy. It would ripple through politics, security, and our sense of place in the universe. For all of history, the night sky seemed indifferent. Yet now, in less than a decade, it appeared to be filling with deliberate visitors. They began to see a pattern. 3 visitors from between the stars, each arriving with stranger behavior than the last. The coincidence theory held for a moment in conference rooms and comment threads, then unraveled under the weight of data. The alternative, that this was a staged sequence, a deliberate escalation, lodged itself in the minds of those who handled the evidence most closely. Among the handful still cleared to view Webb's raw streams, a quieter, darker hypothesis took shape. What if 3I Atlas had not been wandering aimlessly, but lying in wait, dormant, invisible, or deliberately concealed until a civilization reached a certain perceptual threshold? The timing of its detection felt too precise. For billions of years the galaxy whispered nothing. In a single human generation, our instruments sharpened, and something stepped forward. The possibility that it had been waiting, testing, watching, or scheduling its revelation moved from speculation into the uncomfortable realm of plausibility. Every new observation tightened the noose of uncertainty. The object's brightness varied not randomly but in ways that suggested active thermal control, areas that could absorb or reflect heat on command, modulating their signature to the environment. Its rotation was not the drunken tumble of a shattered rock but the steady metronome of a craft stabilized by purposeful design. Communications engineers listening for background noise began to pick out narrow-band blips, bursts of electromagnetic energy concentrated in tight frequency bands, too regular to be natural interference, too weak for any known transmitter. They resembled packets of data being sent in a slow, patient conversation. The question that pressed on everyone's mind was simple and terrible: data to whom? Efforts to trace the probe's origin were frustratingly inconclusive. Its past path threaded through regions between stars, avoiding the gravitational wells of familiar systems. If it had been launched, there was no obvious launch site. If it had been manufactured, there was no nearby factory star. The absence of a home star suggested an ancient series of launches, a dispersed swarm of reconnaissance devices cast across the galaxy long before Earth became capable of understanding their purpose. If that were true, then Earth's encounter might be only one small moment in a catalog of many, countless worlds already observed and recorded. That thought made the arrival feel less like contact than entry onto a long-established guest list. Why, then, reveal itself to us now? Was there a trigger built into the probe's design that matched some threshold of detection, technology, or behavior? Or had we simply wandered into its field of view at the wrong, or right, moment? Inside the agencies, the debate hardened into policy. One camp argued for caution: do nothing overt, avoid drawing attention, treat the object as an unknown risk. Another urged the opposite: active engagement to test whether the probe would respond, and to collect data that passive observation could never reveal. A third group proposed a middle way: carefully choreographed signals, low power and non-directional, sent as probes of intent rather than declarations. Each option carried real dangers. A radar ping might register as an act of aggression. An attempted handshake could be answered by something beyond our comprehension. In a single meeting room, the morality of speaking first became entangled with questions of survival, diplomacy, and cosmic common sense. Meanwhile, analysts returned again and again to Webb's thermal map. Hidden in the subtle rise and fall of infrared intensity, far below the threshold of obvious signals, was a repeating pattern. The intervals between pulses followed a sequence a mathematician would recognize: primes. To SETI researchers, prime-numbered spacing is a classic indicator of intentional signaling, unambiguous in principle because nature rarely writes its rhythms in prime counts. The discovery knocked the debate off its axis. If the probe's heat signature encoded mathematics, then it was not merely an observer. It possessed a basic capacity for deliberate output. Whoever, whatever, had built it had chosen a communicative method that bridged technologies. Heat as signal, a physical variable accessible in the language of thermodynamics rather than radio.